This is Unit 7, Section 6, homework, or not homework, notes, solving log equations. So, first thing is solving logarithm equations with all logs. So I want to solve the equation, check for extraneous solutions. Remember, extraneous just means extra, or solutions that do not work because they are not true. So let's go through this. And the first thing I want to do for all of these is, so if you like to list things out, you can. First thing you want to do is condense all of the logs. So you want to have one log on each side. So let's do that first. Okay, if you remember, since I'm adding these two logs right here, I'm going to multiply this one. I'm going to multiply this and condense it into one log. So I can have log, and then I would have 4 times y plus 5. So I condense it into one log. The other one doesn't change. Alright, so I have one log on each side. Once I get to that point, I can cross my logs off. And it's just like the exponential ones we did with the common base. I write just whatever's left. And now I can solve for my variable. And 72. Okay, now I'm just solving for my x, whatever, just like normal. So I distribute my 4. That gives me 4 times y is 4y. 4 times 5 is 20. 72. Then I subtract 20, because I'm trying to solve for y. 4y equals, was that 52? And then, of course, you divide by 4. And my answer would be y equals, was that 13? And that's it. So condense the logs, get rid of the logs, and then solve. That's really my 3 steps that I'm going to do over and over. Alright, next question. So to condense first, the first thing I have to do is get rid of any coefficients or whatever number's in the front, and it becomes an exponent. So let's write that one down. So this left side did not change, and now I have log 6 squared minus log 4. Okay, I am subtracting, so I'm going to divide 6 squared and 4. So again, the left side did not change. And then I have log, and I can do 6 squared is 36 divided by 4. Now, I have one log on each side, so I cross those off, and that leaves me with 2p minus 5 equals 36 divided by 4 is 9, and now I can solve for p. So I add 5, that gives me 2p equals 14, and then divide by 2. My answer, p equals 7. Okay. Now, so far we have not had to check for extraneous solutions, just because it hasn't come up, but it will on this one, which is why it's in the notes, so I can show you how to do that. Okay, so first thing, I got to condense. So I have a plus, which means I'm going to multiply m and m minus 1. So I have log m times m minus 1, and then log 2. Alright, cross my logs off, and then I have m times m minus 1 equals 2. So again, you just cross the logs off, and I write whatever's left. Now I can solve for m. First thing I do is distribute. M times m is m squared. M times minus 1 is minus m. Now notice this one's very different because I have an m squared. So anytime you see a letter squared, you're going to have to factor. I'm just letting you know right now, we're still doing factoring. So if I have an m squared, I want to take my number and move it, or move everything really. So I want to move everything to the same side as my squared variable. That gives me m squared minus m. This 2, when it moves, it'd be minus 2 equals 0. Now I can factor. I do first times last, that gives me -2. Then I can do m. So what multiplies the -2 that adds to -1? Well, that'd be -2 and +1. Okay? And then I solve from here. So remember, you set each equal to 0. Okay, I would add 2 on this one. I would subtract 1 on this one. And I get m equals 2 and m equals -1. So whenever you factor, whenever you got two answers, you got to check both of them to make sure they both work. I'm not sure, I guess this hasn't come up yet in any of this chapter, but it does now. The reason I have to check them is because I cannot have a negative log. Meaning, like I'll go down here for the notes. So I have no negative logs, okay? What I mean by that is if I have a log, some base, and then some a, right? A can't be negative. So I can't be negative on the A. Actually, I can't be negative on the B either. So you can put A can't be negative, B can't be negative. Like I can't. It's not possible. At least not for this class. Okay. So if I have a log with a base and then a number, the base and the number, neither one of those can be negative when I plug a number in. So let's go back to the problem. So I have a 2, right, and a -1. I got to plug both of those in. So let's do that. So I have a log m and a log m minus 1. So look, if I did log m, right, if I plug my numbers in there, it would be log of 2 and then log of -1. I can't have a negative, so that means -1 is out. Now I'll just check the other one just in case. I only got to check the one number now. So if I plug in a 2, that'd be minus 1. I'm going to have log of 2 minus 1, which is 1. That's okay. So that one would actually be my only answer. So m equals 2. So if I plug a number in and it makes the log negative, then it is not a valid answer. It works for the factoring, but it doesn't work with the logs because logs just cannot be negative ever. Okay? So plug it in, check it. As long as it's positive, then you're good. If it's negative, then don't write it down. It's not an answer. Alright, now we're going to solve logarithms with some logs. So above we had everything was a log, now we don't. So these steps are a little different. The first thing is there's two things I can do. I need to either get the log by itself, get all logs on one side, and then condense. Let's just put it that way. So I need all logs on the same side of the equation, and then I have to condense all the logs, and then I can convert. Those would be my first 3 steps, okay? So first thing is, get all the logs on the same side. Luckily, I only have, why did I do that? On this one, I only have the one log. So all my logs are on the same side. But I need to get all the other numbers to the other side. So that 7 has got to go. Okay, so that means I'm going to add 7 to both sides. That gives me log. Why does it keep doing that? Technology, right? Alright, so I have log base 3 and then 4x plus 9 equals 7 minus 3 is 4. Alright, so I got all the logs on one side, I got all the numbers on the other side. I've condensed all the logs, I only had one, so I didn't have to condense anything. Now I get to convert. So to convert, remember we have base, a, and x, right? And I want b to the x equals a. So I'm going to convert this. So I'm going to have 3 to the 4 equals 4x plus 9. I can just convert it. Now I can solve for x, because now log is out. I can keep going from here. So to solve for x, well, first let's do 3 to the 4th, of course, is 81. Okay, so I'm going to solve for x. I subtract 9 from both sides. That gives me, what, 72? That's 4x. Last thing I do is divide by 4. So x equals, let's see, what is that, 18? And that's my answer. So you get all the logs on one side, all the numbers on the other, condense the logs, convert, and solve. Alright, number 5. So all the logs are on one side, all the numbers are on the other. Now I just got to condense these logs before I convert it. So this 2 comes up here and becomes an exponent. So I got log x squared minus log 4 equals 2. Okay, now I am subtracting, so I'm going to divide x squared and 4. So I got log x squared over 4 equals, oh, not 1, 2. Okay, now I can convert. So, convert. Remember, I need b, what in the world? Okay, I need b to the x equals a. So, I don't have a b, but that means that b is 10, right? So there's my b, here's my a, and then here's my x. If you need parentheses around these, you can do that, like this. There's my a. That, I mean, doesn't change anything. So, b is 10 squared equals x squared over 4. Alright, 10 squared is 100. X squared over 4. Now, because I'm dividing by 4, I'm going to come over here and multiply. That gets rid of it on this side. So I have 400 equals x squared. Of course, the opposite of square is square root, right? That gives me plus minus 20 equals x. Because remember, if you add a square root at any point in any problem, you always have to include plus or minus. Now, because we have two answers, that would actually do a positive 20 and a negative 20, right? So just like before, when we had two numbers, we had to check them to make sure they both worked. So if I go back up here and I plug in, so I have log x, or 2 log x, okay? I'm going to plug both my numbers in. I cannot have a negative. So if I do 2 log 20 or 2 log negative 20, this one is okay because my log 20, that's a positive number. This one is not because my 20 is now negative. I cannot have negative numbers. Therefore, the 20 doesn't work. Or the negative, sorry, doesn't work. So my only answer is x equals positive 20. So anytime you have two numbers, you just got to check them both real quick. Sometimes both work. A lot of times both will not work. Like one of them is going to be your extraneous. Alright, last thing on here, number 6. Okay, all my logs are on the same side, all my numbers are on the other, so I just have to condense. So I'm adding, which means I will multiply x plus 9 and x. So I have log 6, and then x times x plus 9 equals 2. Okay, now I can convert. So I have base, okay, so I have 6 squared equals x times x plus 9. Now I can solve for x like normal, right? I distribute my x, and then 6 squared is 36. Then I got x squared plus 9x. Now look, I have something squared again, so I have to take this number and move it over here. That gives me 0, and then x squared plus 9x. 36, when I move it, becomes minus 36. And now I can factor because I have something squared, right? So I do first times last, negative 36. That gives me I have two parentheses, right? So what multiplies to negative 36 and adds to positive 9? 12 minus 3. Okay, now I solve these, so I set them equal to 0 and solve for each one. If you know the shortcut, that's fine, you can do that. I'm just going to show the work for those that need it. So you get negative 12 and 3. I got two answers. I got to make sure none of them make it negative. So let's go see. I have two things to plug into, right? I have log x and log x plus 9. I can ignore the bases on this part because the base is already a 6 and that's okay. So log x. So when I plug this in, I would get log negative 12. I cannot have a negative, so that one's out. And of course, if I plug in 3, that's fine. So then my other one is plus 9. So when I plug in that one, and I do 3 plus 9, that's positive 12. That's totally okay. So my answer, my only answer is x equals 3. So no negative 12 because it makes it negative. I cannot have that. Even if I plug in negative 12 in the other one, negative 12 plus 9 is still negative 3. Either way, that one is out because it makes both negative, and I cannot have that. And did it freeze on me? There it goes. So that's how to solve logarithm equations with all logs and with some logs. And if I remember right, that should be it. Yes. That is it for section 6.